Hello, my name is Abby, and this is Physics Lab number 1, Charged Tapes. The purpose of this lab was to use two charged pieces of Scotch tape to see how excess charges can exist in our day-to-day lives. We can use these results from the experiment, and these interactions can be simulated on GrowScript, and we can predict the charges of the tape. The overall results show that the tapes have the same charge, resulting in repulsion when they are close. The electric charge on a piece of tape is 1.35 times 10 to the negative 8th coulombs, and each piece of tape was deficient of around 8.46 times 10 to the 10th electrons. Some of the fundamental principles used in this lab are Coulomb's law, which gives the electric force between two charges, Newton's second law, force equals mass times acceleration, which we use to calculate the gravitational force, and that the tape is in equilibrium, so net force equals 0, so F net equals Fg plus Fe. Some assumptions we made was that we neglected air resistance. Each tape was acting as a point charge, as you can see here, and each piece of tape has approximately the same charge. This is an overview of how I had my experiment set up. I said that the system was just the upper tape and the surroundings were the lower tape and everything else, and I include the lower tape here because it was acting upon the upper tape and making it rise up. The initial condition was 3 total pieces of tape on my desk. I peeled the upper tape quickly off from the other pieces, and I determined the charge of the upper tape by holding it near other objects, and I found that it was positive. I hung the upper tape between 2 books, and the lower tape was below the upper tape, and I measured the distance between the upper and lower tape as they repelled each other, as seen in this image right here. While completing the experiment, I noticed that the 2 pieces of tape repelled each other, which means that they have the same charge. The upper piece of tape was attracted to a plastic pen with a negative charge, so I concluded that both pieces of tape were positively charged, and the tape was also attracted to my hand. Here's some of the data and measurements from my experiment. I found that the mass of the tape was about 0.0002 kilograms, the length was 0.2 meters, and the width was 0.02 meters. The measured distance between the 2 pieces of tape was 0.029 meters. F net is 0, and the force of gravity was around 0.001962 meters per second squared. The charge on the tape was found by rearranging this equation down here, which is Coulomb's law, and I found it to be 1.35 times 10 to the negative 8th coulombs. I calculated that the total number of atoms was 1.3 times 10 to the 17th, the total number of deficient electrons was 8.46 times 10 to the 10th, and the ratio of electrons to atoms was 1 electron per 1.54 times 10 to the 6 atoms. So here's my GlowScript code. Up here I have a lot of constants and a couple initial conditions from my experiment. Here is where I have the objects, which is just the bottom tape and upper tape shown in the end. Here's where I calculated my distance vector, which is r. This is where I calculated the gravity acting on the top tape, which is just mass times acceleration, so tape mass times the force of gravity. I calculated the charge of each tape, which is what I had on my slide earlier where I rearranged the Coulomb's law equation. And then I have the electric force, which is again Coulomb's law. And then I also printed out some of these calculations so you could see the answer. And I show the gravity vector, like the force of gravity vector, and the charge force on the upper piece of tape. And you can see here is the upper piece of tape shown as a point charge and the lower piece of tape shown as a point charge, and some of the calculated results printed here. So there were a couple similarities and differences between the data and the model. So both had the same numerical values for the magnitude of the gravitational force, electric charge, and electric force, but GlowScript did have more accurate numbers because they were calculated down to further decimal places. Some possible sources of error include the assumption that the tapes acted as point charges, when in reality the charges are distributed among the entire piece of tape. The charge also may not have been completely accurate on the tape. This could be a result of the humidity lately and also human error when creating the charges. What if electrons had positive charge and protons had negative charge? What would change about the observations I made with the tapes and other charged objects? So the 2 pieces of tape would still repel each other because they would still have the same charge, and the tape would still interact the same with other charged objects because if electrons were positive and protons were negative, then they would still be opposites and they would still attract, or if they were the same charge, they would still repel. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So the charges are created during experiments, so they're not permanent, and when the tapes are brought into contact with other objects, like our hands, they have the potential to gain back electrons they could have lost or to have their charges change. In conclusion, we can model point charges using everyday objects. Objects can be easily slightly charged, and we can use Newton's second law and Coulomb's law to calculate electric charge.